OpenIPC is one of the most exciting developments in the world of FPV, kind of ever. You see, digital FPV made a big splash in 2019 when DJI released their digital FPV system. And since then, we've got systems like DJI, Walksnail, and HD0 so that people who want to go digital have their choice. But there's something about those systems that people wish was different. And that is they wish that they were open source. They wish that they were not proprietary, based on locked down hardware that you could only get from one manufacturer. And yeah, I know that HD0 is open source in a lot of ways that DJI and Walksnail aren't. But even HD0, for all their commitment to open source, you cannot make an HD0 video transmitter or video receiver without buying a proprietary chip from HD0. So wouldn't it be nice if there was a digital FPV system that used off-the-shelf hardware and open source designs, open source software that anybody could get, anybody could make at low price? Yes, it would. And that is what people are so excited about when they talk about OpenIPC. But until now, the technological hurdle of getting into OpenIPC has been so high that every time I think, maybe I should make a video about OpenIPC today, I look at the instructions for how to actually set up the hardware, and I go, maybe another day. But today something has changed. You see, this is the very first, as far as I know, the very first piece of off-the-shelf OpenIPC-based hardware that can just be bought by a consumer and, at least nominally, used on an aircraft. So, does that mean OpenIPC is here? Is it time to jump ship? I'm Joshua Bardwell. You're going to learn something today. Can you guess what the answer is going to be? Actually, there's not just one, but two OpenIPC video systems that you can buy right now. One of them from Runcam, that's this one, and one of them from Emax, that's this one. And originally, I recorded two separate videos reviewing the Runcam and then the Emax system. And I realized that if you're going to watch one of the videos, you really have to watch the other one. And I couldn't take the chance on somebody seeing just the Runcam video and thinking that's all there is to it and missing the Emax one, or vice versa. So I'm going to combine these two videos into one, and I'm going to edit it down and edit it together so that hopefully it's as seamless as possible. But if, for example, you notice that I'm wearing different clothes in one and the other, or if it feels a little bit like I've just kind of shuffled together two separate videos instead of kind of filming them as one coherent whole, that's why. Let's start by taking a look at the physical form factor of the board, and the first thing you're going to notice is it's pretty freaking weird. There are these two standoffs, and then the board is not in a stack, but it is in kind of a zigzag configuration, and it doesn't actually come that way. It comes in a stack with one board on top of the other, but in order to insert the SD card here in this SD card holder, you have to separate the boards. I guess theoretically, you could get in there with the tweezers and kind of feed it in, but it feeds in from this side. And so in order to get the SD card in there, and that SD card is not just for DVR, but also, as you'll see later, for configuration. So you are going to need to be inserting and removing the SD card. It's a little bit cumbersome that they did it this way. You'll also notice that this Runcam video transmitter has only two standoffs. It has only two standoffs. Even when the boards were stacked on top of each other, you can see that there are spots here for two more standoffs, but there are not matching spots here. And so basically what you've got is two boards in kind of a U-shaped configuration, and obviously that's unacceptable. Like, you put that on a quadcopter, you crash the quadcopter, they're going to all be slapping together, they're going to break. This is not finished hardware. And that's the first thing I want to get out of the way as we go into this video. This is not finished hardware. This is a major step forward in that it is a piece of hardware made by a major FPV manufacturer that anybody can slap down their money and buy, and they can start using it. This is the least amount of work you've ever had to do to get into OpenIPC, but it's not a finished product. It is very, very alpha. So the person who should be thinking about buying this is a person who wants to get in on the alpha with less of a learning curve and less of a hurdle, not a person who's looking for a finished video transmitter. As long as we're sort of making meta commentary, I also want to say, especially to the guys out there, I learned a lesson from how I got into Express LRS. I got into Express LRS late in the game, after a whole lot of people were really dedicated to it. And I put my foot in my mouth a couple of times as I was getting in there. And I don't want to do that here. I want to be really clear that what I'm talking about in this video is this specific piece of hardware and not the OpenIPC project as a whole, because I'm just not familiar enough with the OpenIPC project as a whole to really comment on a lot of things. And the main reason is that every time I think about doing that, my freaking head starts swimming and I go, no, not today. So disclaimer applied. There are two boards here. One is the board that interfaces with the camera, and that's the board on bottom. And then the other is the radio board, which is actually just a customized Wi-Fi module with two antennas coming off of it. And when you hear Wi-Fi, you may be thinking, well, Wi-Fi doesn't have spectacular range. It's a Wi-Fi chip. It's a Wi-Fi module. It is not literally a Wi-Fi transmission. It's being customized with, I don't know, custom drivers and stuff. So it's just a convenient way of getting a radio on a board to transmit your signal for you. You can see that they've got a fan on it. That's pretty nice. In fact, you're going to be hearing that fan later in the video when we power up. It's needed for cooling. And by the way, speaking of cooling, in case you were thinking, well, I'll just take these standoffs out and I'll separate the boards. Runcam says that these standoffs are necessary for heat dissipation, that they carry heat from the bottom board up into the top board and let the fan cool it. I don't exactly know if that, like, how true that is, but theoretically, at least, you're not supposed to separate these boards, which is a shame because it could simplify the mounting pretty substantially. Here we have a MIPI cable going to the camera, and it can take anywhere from 9 to 30 volts, I believe, is the rated input. So basically 2S to 6S. Well, 3S to 6S, I guess, if you want to be strictly correct. If you do get this exact piece of hardware, be aware that this plug, this wire that comes with it, it is not symmetrical. It's wired backwards on one end from the other end, which means that when you plug this in, you need to pay attention. You can actually read. Well, I don't know if you can read it on camera, but it says here V in, ground, TX, RX. And you need to make sure that the V in is the correct way around. If you plug this cable in backwards, well, theoretically, I guess you could fry this board. Don't do that. Pay attention to the wiring. It does matter which way the plug goes in. So here is the Emax video transmitter. We've got the main control board here with a SD card slot for DVR and a camera connected by a MIPI cable. This is going to look very familiar to anybody who has seen any other digital video transmitter. The unit can be powered with anywhere from 2 to 6S voltage, which can be direct soldered or powered via a plug. This board here is the RF transmission board. It uses a 5.8 gigahertz Wi-Fi chipset, basically, although it's not doing Wi-Fi. It's doing some custom stuff to get better range than you would normally get from a Wi-Fi system. I've heard people reporting ranges of about 1,000 to 2,500 feet. Of course, that heavily depends on environmental conditions. I'm sure some people have done better and many people will do worse. Now, this video transmitter here is the full-size one, which operates at 800 milliwatts. But Emax has gone one step further and come up with this nano-sized one. It operates at 100 milliwatts and is intended for smaller drones. Well, like tiny whoops, I guess. And we can see that this is a single board solution with a 14 millimeter sized camera. The OpenIPC board and the Wi-Fi board are on a single PCB, and what does it weigh? Just 11.5 grams. Well, that's not nothing, but it's not bad. It could be better. It could be worse. As far as video receivers go, Emax has two of them. One of them operates at 100 milliwatts, and one of them operates at 2 watts. And if you're thinking, well, why does a video receiver have an output power? It's because these digital video systems are bidirectional. So the receiver also transmits to the transmitter, and really, we should call it like the air unit and the ground unit if we wanted to be pedantic, but that's not usually how we think about it. The range of the link is going to be affected by both the video receiver's transmit power and the video transmitter's transmit power. So the maximum range is going to be achieved with the 800 milliwatt video transmitter and the 2 watt video receiver. And presumably, if you were to use the 100 milliwatt video transmitter with the 2 watt video receiver, you just have a lot of extra power here coming from the receiver, and this would be your limiting factor. So presumably, these two are designed to be paired up together, although it probably doesn't matter very much. I would probably just get the 2 watt one, and then whatever video transmitter I'm using, that at least I know my video receiver isn't limiting my range. Now, if you look closely, you will see that there is no HDMI port on the video receiver. These do not output HDMI, they output USB. And the way it works is that they connect to your smartphone via a USB OTG adapter. I'm going to demonstrate this in just a second. And there's an app that runs on your smartphone that is the receiver. OpenIPC actually supports a bunch of different kinds of receiver. The one that we're going to be using is the Android smartphone app. And of course, the performance of that system in terms of latency and processing delay is going to be heavily affected by the processing power of your smartphone. If you have one of the newest, fastest smartphones with fast video decoding, your latency can get as low as about maybe 45 milliseconds. With a dedicated appliance built with a dedicated microcontroller, you can get that latency down closer to maybe 30 or 35 milliseconds. And if you have an old smartphone or a slow computer, then that latency could be, well, it could be unusably high depending on how old it is. That's one of the things about these open source projects is that the hardware isn't locked down in a controlled way. That means you can get sort of consistent guaranteed performance. But in a way, that's kind of part of the fun. What Runcam is doing is providing you with this Wi-Fi adapter. Let's test the latency. That's a good thing to do. How am I going to test the latency? Because my Android phone is the display, and I use my Android phone's camera to record the high-speed footage to test the latency. Crap. I'm going to just steal the latency from Madstech. Madstech, what's the latency?
Now, obviously, JB was far too lazy to actually do his own in-depth technical testing, so instead, you're going to have to put up with me. Now, when it comes to testing latency, it is a complex subject, and I've been doing a lot of it over the last couple of days on the OpenIPC system, comparing it to the likes of DJI FPV, HD0, and others. My testing so far has shown that OpenIPC is capable of latency as low as 25 milliseconds. My tests on the Runcam ear unit that I've got in this quad here are coming out a little bit higher than the numbers that I'm seeing on a DIY OpenIPC setup, but there isn't that much in it. Now, on this chart I've popped on the screen, you can see here the OpenIPC setup on the left with the Runcam ear unit. We've then got it compared to the DIY setup, DJI O3, DJI Goggles 2 with a Vista, as well as the OpenIPC system on a smartphone ground station. The very basics are OpenIPC at the moment is comparable to the likes of a Vista on the Goggles 2. It's not quite as low latency as the likes of DJI O3, but it is definitely capable of getting into the mid 25 millisecond mark, and maybe with some tweaks in the firmware in the future, it may be directly comparable. Today, it is very similar to the likes of a Vista on the Goggles 2 or O3 in the 60 frames a second modes. With regards to how it performs between different ground stations, what you can see is that there's a big difference between my tests on both the Runcam ear unit as well as the DIY ear unit on a set of FPV goggles compared to the test on the Samsung phone on the far right hand side. So the latency behavior that you're going to get from the system is going to heavily depend on your choice of ground station. Now, as JB was far too lazy to do this himself, I will be publishing a lot more content, not only on my latency testing, but the OpenIPC system itself. And if you're interested in seeing that, hopefully there will be a link to my channel in the description below.
Now, I do have to acknowledge that those results were for the Runcam system, not the Emax system, but they're based on the same thing. And we shouldn't assume that they're the same, but I think we can assume that they're not going to be radically different. So the latency of this system is going to be at its best, like, acceptable. Like, people fly DJI at 35 milliseconds to 50 milliseconds latency and consider it usable, but certainly not ideal. But DJI at its best will get down closer to 20 milliseconds. Walksnail at its best gets down into the 16 to 19 millisecond range if you're using the racing mode, and Analog and HD0 can get down as low as 4 to, say, 15 milliseconds. So we've got a flyable latency here, but certainly not class leading and certainly not ideal for stuff that requires very fast response like racing. I'm pretty intrigued that the bitrate shows just 4 megabits per second. And in the text file, you can actually turn it up to, I think, 8 megabits per second. But I'm surprised because, like, DJI does 25 to 50 megabits per second. And that's, like, more. That's better, right? So is the image quality going to really suffer once we get a moving image? I mean, 4 megabits per second is fine for 720p with a static image. But as soon as it's moving, that's when you really need the bit rate. Going back to the question of quality of life and is this ready for prime time, here's another thing that you probably wouldn't accept if you were like trying to have a daily driver FPV system. If I want to change the channel, and you can see here, we got a bunch of channels here, blah, 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 48, 72, et cetera, et cetera, et cetera. If we look at the channels there, how do you change the channel? You go into the text file and you change the channel. So, hey, I showed up at the field. I need to change channels so I don't conflict with you. Great. Pull out the SD card. pull out your laptop and modify the text file, and now you're on a different channel. There also doesn't appear to be like an auto search or anything like that. You just have to manually know, you have to know the channel you're on and manually set it. These are the kind of things that before this is a fully complete, fully mature system that's just ready for people to use would obviously need to be solved. Really, none of these options are automatically determined as far as I can tell. If I set this wrong, we're using the H.265 codec. If I change this to H.264, it just stops working. It doesn't go, no, you're using H.265. There's nothing like really automatic about it. It's just like you set the options right or it doesn't work. And if it doesn't work, F you, good luck. Now it's time to take it out for a test flight. And before I do that, I want to show you the lengths I've had to go to get the recording that you're about to see. Because this is actually the second time that I've done this. And the first time that I did it, the DVR recording created by the app that runs on the phone that works as a video receiver, it was all glitchy. It would kind of play back, but it had weird artifacts in it, and nothing I did could rescue it and make it usable. So we start here with the receiver, and the receiver goes into the phone. But the receiver doesn't go into the phone, because instead of going into the phone, the receiver is going into this little adapter. And this adapter, in addition to acting as a USB OTG adapter, also gives us HDMI out. And that HDMI out is going to go not directly into the goggles, because that wouldn't let me record the feed. Instead, it's going into this HDMI splitter. That splitter feeds into the goggles and feeds into this laptop, which is going to be recording using OBS, using the highest possible quality. Yup, that's what we've got to do to get a good quality DVR. Now, I want to be really, really clear before the comments blow up with me inaccurately misrepresenting the capabilities of the OpenIPC system, that's what we've got to do given the hardware and software that are available to me at this moment. And I'm 100% sure that there's other stuff out there that would do a much better job, more compact, easier, etc. But that's kind of the beauty and the curse of these open source projects, is that sometimes it works really well and is easy to use, and other times you're kind of just cobbling it together, making the best of what you got. And for the YouTube comment section, can I point out the antennas are not on these goggles. The antennas are over there on a mast at about head height, just to give the fairest representation of the signal strength. And I have powered down the DJI O3 video transmitter, so it's not interfering with the test in any way. We're already getting some glitching in the image. I'm not sure why. We're just sitting here. It looks kind of blurry. Not gonna lie. And just the up tilt here. Okay. I guess that makes sense considering it's a 3 or 4 megabit per second signal. Let's arm. Oh, there we go. Here we go. Huh. The latency is not great. I can definitely feel it. Oh gosh, wow. We're getting a little bit of extra latency going into the HDMI input on the HC0 goggles, but compared to the downside of trying to fly off a screen, I'm terrible at flying off a screen. I'm just so not used to it. I feel like it's fair. And we know numerically what the latency numbers are, so feel really, oh gosh. Shouldn't enter into it too much. The glitching that we're getting, where the whole bottom, there, like that, where the whole bottom half of the screen just kind of becomes a mess, is unfortunate. The image quality from the camera looks okay. Like the sun just came out and it's nice and super bright. The camera is fairly dark. The exposure algorithm or whatever is fairly dark when it's darker out. This is okay though. I think the Runcam camera looked nicer. Not in terms of the amount of image detail. I think they're about the same in terms of the amount of image detail. I feel like OpenIPC is really what's limiting us there. But in terms of the exposure algorithm, the color, and so forth. But here under this nice bright lighting, this is doing pretty good. Oh gosh, oh gosh. Oh wow, that's just unacceptable. Like, it doesn't seem to have anything to do with how far away I am. I mean, I guess I did just kind of fly down by the road. That glitching is really distracting. And it's so unpredictable. It doesn't seem to have anything to do with the bit rate. The bit rate is hanging in there. The bit rate is hanging in great, 4.2 megabits per second. It's not dropping at all. I mean, considering it's only 4 megabits per second, like, it should be easier for it to like hang on than if it were like 50 megabits per second, right? It's harder to hold a higher bit rate, but it's staying pretty solid. But the glitching just seems to happen regardless. And oh, frame dropping, wow. Yeah. I would not enjoy flying this as my like daily driver. I'll say that for sure. I just would not feel confident putting it somewhere risky. Not because of the latency, which just to a large degree, I mean, you can compensate for latency with skill just by like dialing back the riskiness of the maneuvers that you attempt. And then like, obviously that's not ideal. You want to be able to do risky, high precision maneuvers. But if you're flying a high latency link, you just go, okay, well that's off the table, and you do other things, right? But like the fact that at any moment the link could just like glitch out, that's not confidence inspiring. Let's try to fly. Oh boy, okay, latency. Let's try to fly over here. And let's just see what happens. I can't punch out. I feel super nervous about the fact that I can't just punch out if things get bad. 4 megabits per second, bit rate's holding in. Bit rate's holding real solid. Like, that's good. Oh, it's getting so bad. No, I don't believe the bit rate. What does the bit rate even mean? Oh, when the picture gets that pixelated and glitchy, what does the bit rate even mean? The bit rate isn't dropping, but the picture is definitely getting worse. So is the bit rate really telling me what I need to know to judge? I don't know, man. Okay. Oh, okay. I feel like, let's do one more thing. I want to take this over. I'm not going to take this super far away because I don't trust that I won't lose link and failsafe or something. And the GPS rescue on this bird is not working at this moment. And so I can't just use it to save me. But I do want to kind of come over here in this field and like see how the link holds in. Because, oh gosh, climb. Because like right about here at the end of the road here is where Walk Snail and DJI kind of get shitty. And that's not just the distance. There's trees and there's a little bit of a hill in the road. You know, there's all these other things that mean that that's where it breaks up. But I know that that's about where it breaks up. And I kind of want to see, oh, it's so glitchy though. Can I put it in angle mode maybe? And that'll help me punch out if I need to. Okay, angle mode. Oh God, I have angle mode. The rates are so slow. Let's see if I can just, oh, whew. Oh God, no. Okay. Okay, get it out of angle mode. All right, that's enough of that for now. That's enough of that for now. Sheesh. That's nerve-wracking. I gotta get GPS rescue working if I'm gonna do that. Sheesh. Now let's do the exact same experiment with the Runcam OpenIPC system, see how it stacks up. And I don't know how it's going to stack up, but we should keep in mind that neither of these systems is really performing at the limit of what OpenIPC is capable of, especially because, like any early open source project, OpenIPC is going to get better and better and better as time goes on. But still, wouldn't be a good video if I didn't compare them both heads up. And that's what we're going to do now. Oh, well, nice to see. We've got the exact same glitching on the screen. The Runcam camera is significantly brighter than the Emax camera. It's a little hard for you to tell that right now because you can't see, or maybe you can see if you look at this camera view, that it's gotten way darker. It's cloudier now, whereas it was sunny before. And yet, as I look in the Runcam camera, it looks fairly bright. Here we go. I'm not encouraged by the fact that the millisecond readout shows 27 milliseconds, whereas normally it shows like 10 or 11. But anyway. Let's get her in the air. And, oh God, the breakup is... it's still there. I mean... We have to compare it to the Emax one, right? That's like, how could we not? In terms of image quality, it looks pretty much the same. Both of them have pretty blurry image. Oh, we have a dead tree here. How long has that been like that? Has that tree been... Oh, interesting. Yeah, in terms of image quality, it's pretty similar to the Emax one. I kind of expected that. I don't feel like the system is likely to be at the point where there's going to be this radical difference in like the ability of the video link to carry the data. Just like the Emax one, we're getting these crazy like breakups where the whole screen just gets the Runcam one is worse. Like the Emax one, I don't remember getting whole screen glitches like we're seeing here. Whereas it was like half screen glitches, still pretty bad. This seems glitchier. Oh gosh. One reason, whoa God, oh my goodness, I'm sliding on ice. That was fun. One reason it may be different is that the Emax video receiver has 2 watts of power, whereas the Runcam one doesn't appear to be a specialized piece of hardware. It just appears to be a Wi-Fi adapter. And its output power presumably is not 2 watts. That's pretty high output power for a piece of off-the-shelf hardware. And remember that because this is a bidirectional, this is a bidirectional system, that we're going to see difference in range based on the video receiver's power as well as the video transmitter's power. In other words, the ground station as well as the air station. I don't know how confident I'm going to feel flying this radically far because of the way it's breaking up. It is super glitchy compared to the Emax. Yeah. Okay. Like, I'm tempted to try to do some kind of a range test, but I'm kind of like, also in a sense like, oh boy, no. Ooh, oh God, the way that the image sort of rolls makes it look like the quad is moving, like I'm falling or something. It looks enough like the quad is moving that it makes me want to respond to it, except I could just have enough cognitive ability to know that's not true. But it is really, okay, I gotta land. It's gonna give me motion sick at the very least. Wow, that was crazy. That was crazy. Like, as an experienced FPV pilot, I know that when I put in right roll, the quad rolls to the right. So there's this link between what my eyes see happening and what my brain knows should be happening, and I don't get like motion sick or anything. But I finally had the experience that other people have when they're just spectating FPV and they're not used to it, and they say, oh, it makes me feel motion sick, because all of a sudden the quad is going, ugh, and I didn't tell it to do that, and I can tell it's not really doing that somehow. It's a video link. Wow. That is much worse. That is much worse. Much worse. Holy crap. Whew. I've held off making any content about OpenIPC until now because I wanted people to be able to just swipe a credit card and get something usable, that they didn't have to jump through a million hoops to get it basically working. And that day is finally here. Right now, you can go to the links in the video description below and buy either the Runcam or the Emax OpenIPC hardware, and you can use OpenIPC. That is a fact. Now, these are pre-orders at the time I'm releasing this video, and they are limited runs, so they will sell out pretty quickly. And that's because this is not finished hardware. And that's not just because this is an early open source system and it's going to get better, although it is because of that. This is even Emax and Runcam say that they're going to continue to work to make this better, and they just want to get this out into people's hands and get feedback from them and just get more people using OpenIPC, because one of the challenges for an open source system is that it has to reach a certain critical mass of user base that then it can continue to grow and support itself. And OpenIPC, I think there's some concern that OpenIPC isn't going to get there if vendors like Runcam and Emax don't get on board. So kudos to Runcam and kudos to Emax for doing this. They're probably not going to make a lot of money on this. They might even lose money, but OpenIPC is a project that is potentially too important to just sort of let wither on the vine. Should you buy this? Well, you've watched the whole video and I think you've probably made up your mind, but if you want my opinion, it's clear that these are not finished FPV video systems that are ready for use as your daily driver. No one is going to be replacing any other analog, HD0, DJI, or Walksnail as their daily driver using this hardware. The hardware is very janky, it's very premature, and the performance of the link is very premature, not reliable enough, at least in my testing, to be able to use it as a daily driver system. But there are lots of people out there who are excited about this project, excited about the potential to make OpenIPC jump through hoops that you just can't do with DJI, to work to improve the project, make it better, and potentially, hopefully someday, even get it on par with systems like DJI, Walksnail, HD0, and gosh, maybe even analog. And if you're one of those people, there are links in the video description below where you can pick this system up, and more power to you. I've also got links to other resources about OpenIPC, tutorial videos from the OpenIPC developers on how to make the system better, like how to get the Betaflight OSD working in OpenIPC and so on. And if you're interested in getting into the system, you're going to want to go check out those channels because there's a whole lot more depth to this system. It can do a whole lot more than I'm showing in this video, and you're going to want to get into that. In fact, I'm going to put one of those videos on screen right here. It's not one of my videos, it's somebody else, but I think that's the right thing to do. As well, there's links to the OpenIPC project GitHub repo and other links down in the video description below. Go check them out, and I'll see you in the next one.